Artificial Intelligence Dr. www.abcpharma.net/English. User question: what are the underlying neurological causes behind fatigue and exhaustion in older people? Claude AI answer: there are several underlying neurological causes that can contribute to fatigue and exhaustion in older people. Let's explore some of the key factors. 1. Neurotransmitter imbalances. Aging is associated with changes in the levels and function of various neurotransmitters, such as dopamine, serotonin, and norepinephrine, which play crucial roles in regulating energy, mood, and cognitive function. Decreased levels or altered signaling of these neurotransmitters can contribute to feelings of fatigue, apathy, and decreased motivation in older adults. 2. Neuroinflammation. Chronic low-grade inflammation, which is more common in older individuals, can affect the central nervous system and contribute to neuroinflammation. Neuroinflammation has been linked to increased fatigue, cognitive dysfunction, and mood disorders in older adults. Pro-inflammatory cytokines, such as interleukin-1 beta, Illinois-1 beta, and tumor necrosis factor alpha, TNF-alpha, can alter neurotransmitter function and contribute to fatigue and exhaustion. 3. Neurodegeneration. Age-related neurodegenerative conditions, such as Alzheimer's disease, Parkinson's disease, and other forms of dementia, can cause fatigue and exhaustion as part of their symptom profile. These conditions are characterized by the progressive loss of neurons and synaptic connections, leading to altered brain function and decreased cognitive and physical energy. 4. Cerebrovascular changes. Age-related changes in the brain's vasculature, such as reduced cerebral blood flow and the presence of white matter hyperintensities, can contribute to fatigue and exhaustion in older adults. Impaired cerebral blood flow can lead to decreased oxygenation and nutrient delivery to brain cells, affecting their function and energy production. 5. Sleep-wake cycle disturbances. The aging process can disrupt the circadian rhythm and sleep-wake cycle, leading to changes in sleep quality and duration. Sleep disorders, such as insomnia and sleep-disordered breathing, are more common in older adults and can contribute to daytime fatigue and exhaustion. Disturbances in the hypothalamic pituitary adrenal (HPA) axis, which regulates sleep and stress responses, can also play a role in fatigue and exhaustion. 6. Neuroendocrine changes. Aging is associated with alterations in the neuroendocrine system, including changes in the production and signaling of hormones such as cortisol, thyroid hormones, and growth hormone. Imbalances in these hormones can affect energy metabolism, mood, and cognitive function, potentially contributing to fatigue and exhaustion in older adults. 7. Sensory and perceptual changes. Age-related declines in sensory and perceptual functions, such as vision and hearing, can increase the cognitive and attentional demands required for daily activities, leading to increased mental fatigue and exhaustion. It is important to note that fatigue and exhaustion in older adults often result from a complex interplay of neurological, physiological, and psychosocial factors. A comprehensive evaluation by a healthcare professional can help identify the underlying causes and guide appropriate management strategies, which may include targeted therapies, lifestyle modifications, and support for overall well-being. GPT-4o answer: fatigue and exhaustion in older people can be influenced by several underlying neurological causes. These causes involve changes in brain structure, neurotransmitter levels, and neural pathways. Here are some key neurological factors contributing to fatigue and exhaustion in the elderly. 1. Neurotransmitter imbalances. 1. Dopamine. Dopamine is crucial for motivation and reward. 1. Reduced dopamine levels, which are common in aging, can lead to decreased motivation and increased fatigue. 1. Dopamine dysregulation is also associated with conditions like Parkinson's disease, which is characterized by significant fatigue. 2. Serotonin. This neurotransmitter is involved in regulating mood, sleep, and energy levels. 2. Alterations in serotonin levels can contribute to fatigue and are commonly seen in depression, which frequently affects older adults. 2. Brain structural changes. 1. Gray matter atrophy. Aging is associated with a reduction in gray matter volume, particularly in areas like the prefrontal cortex and hippocampus. 1. These changes can affect cognitive functions, including attention and executive function, leading to mental fatigue. 2. White matter integrity. Degradation of white matter tracts, which facilitate communication between different brain regions, can impair cognitive processing speed and efficiency, contributing to fatigue. 3. Neuroinflammation. 1. Chronic inflammation. Aging is often accompanied by a state of chronic low-grade inflammation, known as inflammaging. 1. Neuroinflammation can affect brain function and contribute to symptoms of fatigue by disrupting neural signaling and energy metabolism in the brain. 2. Microglial activation. Microglia, the brain's resident immune cells, become more reactive with age. 2. This increased activation can lead to neuroinflammation and neuronal damage, exacerbating fatigue. 4. Mitochondrial dysfunction. 1. Energy production. Mitochondria are the powerhouses of the cell, including neurons. 1. Age-related mitochondrial dysfunction can lead to decreased ATP production, which is essential for cellular energy. 1. This reduction in energy availability can manifest as physical and mental fatigue. 2. Oxidative stress. Accumulation of oxidative damage in mitochondrial DNA over time can impair mitochondrial function, further contributing to energy deficits and fatigue. 5. Sleep-wake cycle dysregulation. 1. Circadian rhythms. The regulation of the sleep-wake cycle often becomes disrupted with age. 1. This dysregulation can lead to sleep disturbances, poor sleep quality, and resultant daytime fatigue. 2. Sleep disorders. Conditions such as sleep apnea and insomnia are more prevalent in older adults and can significantly impact overall energy levels and contribute to chronic fatigue. 6. Cognitive decline. 1. Dementia and cognitive impairment. Neurodegenerative diseases like Alzheimer's disease are associated with severe cognitive decline and fatigue. 1. The effort required to perform daily tasks and cognitive functions increases as brain efficiency decreases, leading to exhaustion. 7. Neuromuscular factors. 1. Motor neuron changes. Age-related changes in motor neurons and neuromuscular junctions can affect muscle function and contribute to physical fatigue.